Hello everyone, welcome back to my YouTube channel. My name is Luvita Pramasari. My student ID number is 19130111035. I'm from 3A Mathematics Education. In this video, we will learn about mathematics logic. So, enjoy this video. Mathematics logic is the sign used to determine the truth value of a statement or draw calculation based on applicable basic rules. In mathematics logic, we'll learn to determine the value of a statement, whether it is true or false. The statement itself is divided into two types, namely, number 1, class statement. Class statement or class sentences are statements that already have true or false values. Example, 7 is an even number. The sentence is false because the correct number is 7 is an odd number. 2. Open statement. An open statement or an open sentence is a statement whose truth value cannot be determined because a change or variable. Example, Px is 4x plus 2 greater than 7, where x is element R. When x equals 1, then P1 is 4 multiplied 1 plus 2 greater than 7 is false. When x equals 2, then P2 is 4 multiplied 2 plus 2 greater than 7 is true. Next, about negation of a statement. Negation is the inverse value of a statement, where when a statement is true, then the negation is false, and when a statement is false, the negation is true. The negation of the P statement is denoted by tell the P. Next, quantor statement. A quantor statement is a form of mathematics logic in the form of a statement that has a quantity. In a quantor statement, generally there are the words all, every, some, there, and part. Words that are whole, all, every belong to a universal quantor, and words that are word part, some, exist belong to the existential quantors. The universal quantors and the existential quantors negate each other. Example universal quantors is all students study hard, and example for existential quantors is some students study hard. Next, about compound statement, equivalent forms, and their negation. In mathematics logic, several statements can be formed into one statement using logical conjunction such as and, or, then and if, and only if. The combined statement is called a compound statement. In mathematics logic, this conjunction is have their own symbol and term. You can see this table. Okay, next, conjunction truth table. From the table, it can be concluded that the nature of the conjunction is true if the two constituent statements of the compound statement are both true. Next, truth table of disjunction. You can see this table. From the table, it can be concluded that the nature of the disjunction is false if the two constituent statements or the compound statement are both false. Next, truth implication table. You can see this table. On the nature of this implication, P then Q, P is called the hypothesis and Q is the conclusion. In this implication, It will be false when the conclusion is false and the hypothesis is true. And the last, truth be implication table. You can see this table. In the be implicative nature, the compound expression will be true if the two constituent statements are the same, both are true or both are false. Next, about tautology and contradiction. Tautology is a compound statement that is always true for all the possibilities, and contradiction is the opposite. That is, a compound statement that is false for all the possibilities that exist. Next, about equivalent form and compound statement. Compound statements that have the same value in all possibilities are said to be equivalent. The forms of statements which are mutually equivalent are like this. Next, about compound statement negation. Conjunction negation is negation of P and Q equivalent with negation P or negation Q. Next, disjunction negation is negation of P or Q equivalent with negation P and negation Q. Next, implication negation is negation of P then Q equivalent with P and negation Q. And the last, negation B implication is negation of P if and only if Q equivalent with P and negation Q or Q and negation P. Next, about conversion, inverse, and contraposition. Conversion, inverse, and contraposition are other forms of implication where the conversion of P then Q is Q then P. The inverse of P then Q is negation P then negation Q. And the last, the contraposition of P then Q is negation Q then negation P. Okay, the next about conclusion drawing. Drawing of conclusion is the conclusion of several compound statements that are interrelated. In drawing conclusion consists of several ways, namely A. Modus ponens, B. Modus tollens, and C. Syllogism. Modus ponens. P then Q is the premise 1, P is the premise 2, and then the conclusion is Q. Next, modus tollens. P then Q is the premise 1, negation Q is premise 2, and then the conclusion is negation P. And the last, syllogism. P then Q is the premise 1, Q then R is the premise 2, and then the conclusion is P then R. For example, number 1, premise 1 is if you study hard, then you is smart. Premise 2 is you study hard. The conclusion of the two premises above is blank blank blank. So the answer is premise 1 is P then Q, premise 2 is P, and conclusion is Q because this is modus ponens. So the conclusion is you are smart. Number 2, premise 1 is if Nina eats a lot, then Nina is fat. Premise 2 is Nina is not fat. The conclusion of the two premises above is blank blank blank. The answer is Premise 1 is P then Q. Premise 2 is negation Q. Conclusion is negation P because this is modus tollens. So, the conclusion is Nina does not eat a lot. And the last example, premise 1 is if Benny is naughty, then mom is angry. Premise 2, if mom is angry, then Benny gets punishment. The conclusion of the two premises above is blank blank blank. The answer is premise 1 is P then Q, premise 2 is Q then R, conclusion is P then R because this is syllogism. So, the conclusion is if Benny is naughty, then Benny gets punishment. Okay, that's all about mathematics logic. Don't forget to like, comment, and subscribe. Thank you.